Okay, guys, I'm starting. So today's lesson is going to be about MVC. And I know what some of you guys are thinking.
What's that?
What does MVC stand for, right? Thanks, Watley. Model View Controller. Not a full sentence, am I right? Yeah, basically the idea here is that we want to have some sort of separations of responsibilities in our code, and the responsibilities kind of fall into these three things: a model, a view, and a controller. That was weird. And what does each one of those do? So a model is a way, basically, that we represent or model some real world object in our code, and usually it also includes the things that either the object can do or that we can do to the object. Think about it, if you were here last week, we had this kind of virtual library of books. We just kept a title for each book. A better model would be more information about the book. So instead of title, we also have the author, maybe the year it was released, could be a description, page count, and then a book can't really do things, so we don't have any actions. If this was a person, the person might have an eat command, which would interact with some sort of food item. But a book is just a book. A person might have, if we have a model for a person, he might have a read command, which would read a book. But since we only have books, they can't do anything. But we can do things with book, right? We can, if we have a library, we can add a book. We can get rid of a book. We can change the information on a book, etc. And a view. So a view is how we define what we see when we examine. And I'm using the word examine instead of like see or view in this case, because it's not just a visual representation. It's more of how do we lay out the code so that, for example, if you're writing an API, it's a responsibility for Vue to determine how other developers are working within, how applications that use your API kind of see in a more abstract definition of the word see your object. So a view might be the difference between using XML or JSON to represent something, or just using plain text or encoding it as binary and so forth. And a controller is the part of our code. I think the pizza is here. That's the part of the code that's responsible for controlling when we show these views and when we activate those actions that we can do to models and then models can do. Basically, it's the thing that ties together the models and the views, and usually the user is actually using our app. And yeah, that's just the basic overview. So I'm actually just about to start coding. So this would probably be a good time to stop and eat. Where'd I put it? How'd I pause it? Okay. So I'm going to continue. Those of you who are joining me in the recording and not in the actual thing, we stopped for pizza. I recommend that you go ahead and stop the video and order pizza right now from Papa John's. And no, they're not paying me for this, but they should. But moving on, we talked about what a model, a view, and a controller is. And now let's actually get started coding. And the first thing we want to do is we want to model a book in our library. So typically, we want to kind of separate our app into individual folders, usually one for controllers, one for models, and one for views. So since what we're doing now is making a model, let's go ahead and make a directory called models. And now we can make a file inside models, and let's call it books.py. Okay. And now, oh, my bad. And now Python has, what's going on here? Why is caps lock a thing? Okay. And Python has something really nice called classes that we talked about in today's primer. And we actually want to use that when we define our models because it makes things a hell of a lot easier to work with. And what we want to do is we want to define a new class, and we're going to call it a book. And this class, we're going to want to define at least one global variable, which is going to be this dictionary that contains all of the books we have in existence. Usually in production, you will actually use a database for this instead of just a dictionary that's stored in memory. But because we're going to have a big talk about databases, I think in 2 weeks or so, I'm just going to be using this for now. And then we want to kind of talk about different things we can do to a book, right? There's the next one. And you know, okay, before we talk about things we can do to a book, let's talk about what we want the book to have in it, right? So far, if we go from last week's example of just a simple server that all it does is it shows you a list of books, all that a book really contained, from our perspective, was a title. It had this implicit ID in it, depending on where it was in our array, but all we really knew about a book is what title it is. Maybe we want a book that could contain the book's author, or maybe even the publication year. You know, so the idea here is that because we're separating all of this out from our code into this separate section of our app that's called a model, it makes it really easy later on to go back and say we want to add things. We want to make it so that our particular model contains more information, or less, if you don't need it. And Python classes. And then we want to talk about the things we can do to the book. And those are usually defined as static methods. So when you talk about object-oriented programming, for those of you who don't have much experience, you have these static methods that are associated with the class, meaning that even if you haven't created a new instance of the class, you just defined what the class is. So the program knows what a book is, but it doesn't have any books kind of in memory yet. Then these static methods could still be accessed. And these are usually operations that deal with kind of like the entire collection of those instances. So to give you guys a quick example, I'm going to define a static method. And we actually use a Python decorator for this, which is very similar to what we did before with routes. That just tells Python that the method I'm defining now is actually a static method. This will be easier to understand when I actually write non-static methods. So let's say we want to have an add method that adds a book. So first off, we want to make sure whatever is provided over there is an actual instance of this method. So I'm just going to say is instance. That's a built-in function. So if book, which is the variable that's provided to me over here, sorry, the parameter that's provided to this function happens to be an instance of book, which is the class that I'm writing right now, then I want to go and into books, I want to index by books.id and set that as equal to whatever object was passed in. So what's happening here is that what's given to me is a book that contains several fields in it, probably the book's title, author, publication date, and then another one called ID, which is, what are you laughing at? Which is the ID of the actual book. And we're going to use that as kind of like the field for our dictionary over here called books. And I'm actually accessing this as book.books because I need to give it this global name for this dictionary, not just a local one. And then I'm actually going to go ahead and have this entire method return true, saying that the book was added successfully. And since this if block actually returns a value, if we are taking this kind of like a if block, if this whole thing gets evaluated as true, then we'll never actually get to this line after the if statement. So it's safe for me to just say return false over here, meaning that if the if block wasn't taken, something must have gone wrong over here when we check to see if it's an instance, and we could just say that the adding failed. We couldn't do it. And that's a static method because it's something that we do before the book is added to the collection. It's something we can do globally at any given time. We might also want another static method, and this one is very practical for finding one. And maybe we want to find one by ID, meaning that we give it some sort of book ID. And what we want to do is we want to return from this from the dictionary we have earlier, basically whatever corresponds to the ID. ID is the key. What returns should be the value. And if nothing, we should probably return none. Yeah, pretty basic. And so you can imagine in our code, we'd probably want to use this particular method when we're showing the user a specific book. So if we're kind of like the /book/book ID from last week's example, we'd probably now want to switch over to using this method, give it the ID over here, and then from that we'll be able to get the information we want from the book, because that's what the function findById returns. Another one that's kind of useful is probably want a function that could return all of the books together, so we could use them on our main page. And we can just call this one find. It doesn't need any parameters right now. And all it really needs to do is probably return, and I'm going to use list comprehensions because list comprehensions are cool. It's going to return basically all the books for, what was it? Book.books.items, sorry, for ID, book in. And the primer today should have covered what list comprehensions are. If you're still unsure, there are a whole bunch of examples by just doing Python list comprehensions. The format itself is actually very similar to the corresponding list comprehension format from just plain mathematics. So kind of being able to do this, yeah, so understanding the way it works is probably also valuable for your math classes. And we do have a primer that should be up for this at the same time that this video is, so you could go back and look at that. And yeah, so we just returned some sort of array of books. Okay. What else should we have? Finding one instance. GenuID, clear. And let's add, yeah, actually let's just go with this for now. We'll write the rest of the model later. And those are basically the static methods we want to have. Now we want to handle kind of like what happens when we instantiate the book, which would be done basically somewhere else in our code. We might have a variable named myBook, and it should be an instantiation of book. But we don't want to instantiate it plainly. We want to give it some sort of parameters, right? And to do this, we need to define kind of like this built-in, init method. And we need to decide what goes into it. All right, so probably want to give it a title. We probably want to give it an author. And then let's give it publication year. Let's just call it year. There's only one year associated. Make it simple. And then what we want to do is we want to define those as local variables. Sorry, I forgot the self over here. We want to define those as local variables to the instance. And self.year equals year. Okay, so I think that should be sufficient. But you notice that one thing is actually missing here. And that would be something that I'm actually using elsewhere in the code. It'll be this book.id, right? Earlier when I defined my ed method, I actually described books as having a field called ID. So it makes sense for me to do something like give it a self.id equals something, right? And I could just give it the ID 4 if I wanted to be truly random. Except we probably want to do something like use a pseudo-random module, for example, from random import rend, is it rend int? I think it's rend int. Oh god, that was a mistake. Yeah, it is rend int. And now what we can do is maybe instead of it, we could give it some sort of random number. So we could just say rend int between 0 and 10,000. Now there is actually a flaw to this logic right now. And those of you who worked with hashes before probably know what it is right away. It's that I could possibly generate the same key twice, right? And we don't really want that. We want to make sure that each ID is unique because it is an identifying, so we call it an ID. So I'm going to make a helper method over here. It's going to be a static method of the class. It's going to be genNewID. And it's going to be pretty simple. Doesn't need to take any parameters. We basically want to create some sort of test ID that's going to be exactly what we have over here. Some sort of random number. And then we just kind of say so long as when we try to access our dictionary over here and we get an actual value, we want to keep on generating a new one. And not particularly scalable, because when you get close to the limit for your for your database, or in this case for the dictionary, which would be 0 to 10,000, you kind of get a lot of what's called cache hits, and we want to miss in this case, I guess, if we want to compare this to caches. But basically, the more filled our dictionary is, the likelier we are to get the same ID more than once, which means that we could just potentially keep on generating new ones and new ones. But I'm just going to keep this while we're doing a small example. If you're interested in actually doing this in a larger scale, you should probably do some extra research. Do not use this method. Later on, when we talk about databases, we'll probably get into more details about how this works. But the nice thing here is that now, instead of just saying that, we could replace the rand in that we kind of coded beforehand with basically calling this static method from book gen new ID. Okay, that looks good. And now when we create a new one, it should be saved. And here's something we can actually try it out if we wanted to. So right now I'm in this folder called lesson05 that has the models folder inside of it. And inside models, of course, I have my model file. And I can actually just run Python from here and say from models dot. Dot is basically, from models dot books. I can say import book, and now I have access to it. It's a class. And I can say, my book equals a new book. And it's going to tell me that I forgot to give it all the parameters we wanted. So let's say that I have a new book called webdev, just webdev. The author was Adam 5 years ago, which would have been, what year was it 5 years ago? 2008. Yeah, now if we look at my book, it's going to tell us, hey, this is a book object, and then going to give us the memory address. Now, who in here actually cares about the memory address? You? You sort of? I bet you do. So the question that I want to ask, and I know the answer to, so don't answer me, is how does Python generate this beautiful string of where the memory is stored? OK, no one answered. Good job. It's actually kind of like init. There's another built-in method called repr for represent. Represent. Yeah, and it takes the object itself, and then it returns some sort of string. I believe it needs to be a Unicode string that represents the object. So we could do something like returning, if this is a string, a Unicode string is just preceded by the letter U. And you can see that Vim is smart enough to color it green, the same as the string itself, whereas otherwise it would probably be white, like that. Yeah, so that just means that unlike normal strings, this string contains Unicode, which means you can do crazy stuff in it, like including Unicode characters. And if you know me, you know what's coming. Where is it? That's right. There's a Unicode character for everything, by the way. Someone thought it was a good idea. He was right. Yeah, but we're gonna keep it a little bit simpler. We're gonna keep the same angle bracket notation that they use because it's a pretty convenient way to represent that what we're showing isn't just a literal value. It's not a string. It's an actual object. And then we're going to say in it book. It has some sort of parameter over here. Maybe its title happens to be that. The author happens to be this string. And then the year equals this integer. Those of you not familiar with string formatting, you should Google that. But all I'm going to do now is basically include the corresponding values. Looks like I'm closing on 80 characters. Let's go to the next line after a comma. Self.author. What did I miss something? Oh, comma. PHP hammer to you. There we go. And that looks good to me. And just for kicks, let's go ahead and run the same thing I did earlier over here. Let's run this line over here to import. And then we define my book as the classical hit by Adam from 2008, webdev. And now if I try and represent it, instead of getting this kind of useless bit of information, we get something that's actually meaningful to us. And that's how they do. It's kind of the way that a lot of things behind the scenes in Python are implemented, so that when you display them, you get actual information, not just useless stuff. And right, so those are kind of like the built-ins. It's also nice to have additional instance method. For example, let's have a save method that just saves whatever we currently have to the database. And that's actually very easy to implement. We want to return what our global method book does when we call it with the object we're currently working with. We already kind of implemented it, but we implemented it in a different way. Earlier, we just said that we have this book.add method that adds some sort of book object if it's valid. And now we're saying, well, we know there's a book object over here. Let's just call book. I called app. That was bad. I always do that. And I'm recording. Shouldn't record. I did it again. Go figure. So let's just quickly save it. Basically, in the example over here, when I have my book, I should be able to just do mybook.add. Not right now because I haven't refreshed the console, but in the actual code we can do that. And let's have a delete, just to go along with save. And all this has to be done is basically call book.books and then pop. Pop basically removes something from an array, and it actually returns it, which is why I'm returning what pop returns if it exists. Yeah, so this is actually a pretty complete model to some degree. It's missing a few small things we'll probably get to a little later. But you can see how I can do stuff like import it, create it, and now I can call my book.save. And it's true, meaning that it saves correctly. So now I can do stuff like book.find. And here's an array of all my books. Let's say that a year later, Adam decided to write webdev 2. How do you spell reckoning? There you go. Yeah, and then he saved that book. If I do book.find now, I get all the books. And you can see how these books have ID, like this ID is 2985. I can also do find by ID. And I want to give it 2985, and it should just return to me the one book that I'm looking for. So what we did here is we basically taken all of the logic that we think we're going to need for storing books, for getting a single object, and for representing it so far, and kind of abstracted it into a Python class. And the nice thing here is that it's very modular. So if we wanted our class to have something else, like maybe a genre, we could just edit and make sure that we actually edit it over here. And a nice thing I usually like to do is provide default values for these. Let's not add genre, just so it matches with the example I have. Maybe a default title will be Harry Potter and the webdev. And all books that don't have an author are actually written by Adam, because he just likes to write books. And he writes all of his books in the year 2025. Yeah. And the nice thing about that is that now all I really need to do is import my module. Where's my module? And then I can say my book equals book, not give it anything, and my book will automatically be Harry Potter and the webdev by Adam in the year 2025. So we created a model. This is basically how a model works, how you write it, and kind of how you use it. Most models in most frameworks work pretty much the same way, except that they tend to use databases instead of just dictionaries. And let's actually write our controller, right? We want to do something that control when our app displays our books. And let's go ahead and create our controllers class, controllers folder. And inside of controllers, let's make a books.py for managing books. And let's go ahead and import some stuff from bottle. Let's import all the things, why not? And now we want to go ahead and import our book. And we're going to say from models.books, import book. Now, what I'm going to do now is call this bottle with an uppercase B function, which is actually provided by this bottle module. If I were to just call import bottle, then I would have to do something like this. But since we're importing everything from inside bottle, we could just call that. And I'm going to make this books app. And I'm basically creating a sub-app to my overall app. And all that this one does is it manages books. Later on, when we create our actual app.py, we'll import this and mount it at /books, which will make more sense when I actually do it. But we want to go ahead and last time we just called route of /, for example, to display all the books. Well, since we have a distinct app now, what we want to do is we want to call booksapp.route, because it becomes a method of route. When you call route without this app that it belongs to, it just assumes that you mean to call it on something called default app, which is always created for you. In this case, we're explicitly specifying the name of the app we want to use. And a decorator goes with a function. So let's go ahead and make one called listBooks. And what this one should do is we should just return book.find. Basically find all the books, just like that. Makes sense. And if you guys remember from last time, we had something that looked like this. Basically book ID. Notice that I'm neglecting to include the book. Usually it'll be /books/that. I'm purposely neglecting to do this because what I'm doing now is I'm writing a sub-app, which is responsible for books. Basically, the books controller is considered to be its own app. And so I don't have to designate in my path anymore that it belongs to books, because it has to be a part of it. It's a part of the controller. Books app dot. And this would of course be our viewBook method. It takes a book ID. And what that one returns would be book.findById, book ID. Pretty simple. And now we actually need to write the code that kind of mounts all of that. So I'm going to make an app.py. And I'll give you guys a few more seconds to look at this. Let me open app.py on the side over here. Edit anyway. And this one actually looks like your normal bottle app. We want to do app equals bottle. Notice that this time I'm not actually giving it an identifying name, just the word app is fine. And it has app.run at the end. We can say, when we do this, not app, actually just run app. And we're going to give it the same additional parameters we did before. Our host is localhost, and our port is 8080. And now in between this and the other one, what we want to do is we want to import from our controllers .books. We want to import this app we created, basically that variable that I'm defining on line 6 over there. And then we call app.mount. And this is where we give it the prefix. So under the books prefix, basically place our books app. Let me just hop over to my example, make sure that this is all I need. Yeah. And one last thing that I added in my example code is basically routing root, our index function, if you may, redirect basically to /books, which is where we're storing this function over here, root of the books app. Okay, hopefully this will work. So let me go ahead, scroll over here, and let's see what happens when I do python app.py. It executes, which is a good sign. Localhost 8080. It redirected to /books, and then we get nothing. Is nothing good right now? What do you guys think? Yeah, it's actually what we expect to happen, because what books do we have in our collection right now? Nothing, right? Makes sense when we have nothing. You want to go ahead and save nothing. Let's go ahead and change that. Let's go over here where we're importing book, and let's just hard code a book, right? Book 1 is a new book. Let's call it, what are we going to call it? I had some pretty good examples earlier. Yeah, and let's just only specify the title. Hitchhiker's Guide to the Web Dev. Now let's copy that and change the other one to be book 2 and book 3. And now I'm tempted to call this one the restaurant at the end of the web dev or something, but let's keep the same example we used last time. Web dev, the good parts. And I'm only specifying title, so the other fields will just be the defaults, which should be Adam in 2025. But let's not forget to actually call book1.save, and book2.save, and book3.save. So now we're actually saving them. That's pretty good. Which means that now we have a collection with 3 different books in it, right? So when I call /books, I should be seeing 3 books. Or, an internal error. Unsupported response type. What do you guys think I'm getting that? Good answer. The answer to that is because what I'm doing here is I'm returning book.find, which is a book object. And I can do something like turn it into a string. And it knows how to return a string. We've done this last time. We just return a plain string. But a better approach would be, oh wow, I wrote a lot more than I remember. No, wait, go back. Control, here we go. A better thing to do is we define in our application how a user views a book, when the user kind of goes to our site and says, show me a book. And the way we do that is, you probably guessed it, because I used the word view. We do it by basically going into our same folder as before. Let's close this one. Not same folder. And then we create a new one called views. And then what we want to do is we want to edit a new file inside of it. I'll put it over here. Views of, let's call this one list books dot. And the file format we want to use is TPL. TPL stands for, I guess, template is what they call it. And that's built into Bottle. So you just have to create a TPL file, and you're pretty much set. And this is a file called listbook. It makes sense to put a list in it, just plain HTML. And now we want to say that for every book in our books, and that's just basic Python, we want to do something. We want to display a list item that contains, let's say, a paragraph which should be book.title. And this double curly brackets just means take whatever this Python expression evaluates into and put it there, exactly as it should appear. li. And since we're not using indentation the same way as you do in Python code, we need to explicitly tell it when for loops end. So we're just going to do that. And let's see what happens. Actually, let's not. Let's finish. Let's actually make it working this time before I move on. The problem here is that I'm still returning book.find instead of calling, instead of actually activating my view with it. So a better thing to do would be to call the template function and give it the name of the template, and then define what books equals. Yep, so just books equals book.find. And let's not forget to close our parentheses. Now this is pretty exciting because I think it's going to work. There we go. We have a list. Basically, we define a view and telling it this is how humans would see this collection of books. So go ahead and show it this way. Works pretty well. And let's do the same thing kind of quickly for view book. We want to show a template. Let's call this one view book. And it's going to have just book equals that. And then if this is called this book.tpl, let's make view book.tpl. And let's see, view book. And let's just let's use H1s. Who doesn't like H1? Book.title, and it's by book.author. H2 would be, let's say, book.year. That's all we need. We could just go over here. Unexpected end of file. But I forget. End of file in which file? Import books app. App.py. Looks like I modified it by accident. Okay, I have end of file over here. I forgot a parentheses. Yes. So this still works. I have no idea what's the ID of this, so I can't access it. We can actually fix that pretty easily. All we have to do is go to our list books, and maybe instead of just a p tag, we make an href equals /books /book.id. Expand it. Close it. And now rerun our server. Now all of those are links. Specifically links to the page that correspond to each book. Okay, so we basically, now we can see how we made a model view and a controllers, how they all work together. And one thing that I want to do is actually make this a RESTful server, because all we can do now is view books. We can't add any. We basically can't really do much. And the way that all of this kind of work goes into is this books.py, where we define all of our routes, the controller. And we can do a thing like books app.route. Basically, when we method equals post. So when we post to our root app, we want to add a book. And what this needs to do, basically needs to create a new book. And the book basically gets data from the actual information that's provided to us. Let me save a little bit of time and just copy a little bit of code I have. Great, can't do that. Go up. Yank. Okay, so this is some code I wrote earlier that all that it does, I need to get rid of that line over here, is it kind of fetches title, author, year, description, not description, and it saves all of those, and it creates a new dictionary to use those. And then it basically checks to see if all of them exist, and if they do, it creates a new book based on this dictionary. The double asterisk here is a cool little thing that takes an existing dictionary with the same names as the parameters that go into the function or class constructor, and then kind of expands them. So if this class takes a title, an author, and a year, that I can usually specify by just saying year equals something. If I have a dictionary that contains a value for year, in this case an int, it'll actually expand it. And the reason why, you can actually write a really clever little thing over here that does this automatically, see if all the things exist. But I'm actually explicitly defining them one by one, because that's kind of similar to what you see happening in real life. Mostly because you want to do some sort of error checking on the information that a user gives you. If they give you an email, you don't just pass it through into your user model initialization. You usually want to make sure what they gave you is an actual email. You know, if they gave you a name, you want to make sure it's a unique username. You want to make sure it's a unique username, so you don't have two people with the same name. And that's basically the functionality you want for creating a new one, which means that we can go ahead and write a corresponding. Where am I? I think I'm in caps lock. I hate caps lock. I need to fix that. And I can go ahead and create a form over here that uses this RESTful API. I just say, let's see, the method is a post, and the action is /books. And I need to create fields for every one of those. Let's see, where do I have that? 6. Well, oh yeah, paste. And I have some input fields, basically using the name. I give the name title, year, and author. And then I want to give it an input of type equals submit. And the value would be what goes in it, so just say add book. Like that. What's the last field for? Author. What's going to happen? God, I'm terrified. I created it. I think oh yeah, I forgot to redirect. Basically, over here where I have my books controller, after saving it, I should probably redirect back to root, which is where I'm showing all of those. No, I shouldn't.
Reader set. Good.
What? I don't see it. Why is this here?
Well, I trusted you to know what her name was.
Her name. I don't know why you trust anyone.
Okay.
Let's just create a new sample book. It's going to be Harry Potter in the webdev. There it is. Harry Potter in the webdev. Okay. I'm kind of running low on time. We may have to cut into the advanced topics today. But let me just go ahead and finish making this RESTful. So we've done, I think I actually split this into logical steps. Yeah, a control, basically telling when the controller when to create a book, another one for when to update, and if you guys remember your CRUD routes, then we want to update some sort of specific book ID, which is an integer always, and we want to do this, designate this with a put method. Okay, and that's actually, you could kind of do this with just some creative copy pasting. Basically, you want to say that if book.find by ID of book ID exists, then we want to go ahead and load it equals. No, it's actually bad to call the same function twice. Whatever. We'll make it work. We want to call it, then we want to change the values in it. And we can basically copy these lines, because the put is going to be the exact same form as what we used for post. So we read the title, the author, the year that's provided to us from the form, and then for each one of those that's actually provided, we want to take, I think I deleted a line I shouldn't have. There you go. This thing should go over here. For each one of those, we want to say my book. We want to use the underlined dictionary for it, and basically saying that the title should be whatever the title is. Same thing over here and over there. Year, author, and year. And that actually modifies it. After we're done modifying it, we can just redirect. And the best place to redirect to would probably be our book ID / book ID, like that. Books / book ID. If we couldn't find it, we're probably going to throw an error using the abort function, something like I couldn't find the book, so I didn't update anything. And that lets us edit a book. Now, there's a small issue over here, which we've gone over last time, which is that put isn't actually implemented in forms. So what we're going to do is called method override. And we're going to do this in kind of like the most seamless way we can. And to show this, I want to load up this view book template, which is where I'm going to put my form for editing. And I'm going to start off by just copying the exact same form we used to create a new book from our listbooks.tpl. And just keeping the method as a post, but I'm going to add another input field. And value a name, method, and value equals put. So what I'm doing over here is I'm including in the form kind of like an input field that doesn't actually, it's counterintuitive, it doesn't take an input, it's hidden, the user doesn't see it, it doesn't show up on the page. And the name for the corresponding field in the request will be _method, and then the value that goes with it is put. That's a very common way that quite a few frameworks, I believe Ruby on Rails and Sinatra use it, Express for Node uses it, and a few other ones use to kind of get around the fact that put isn't implemented. And then I give it all the same things, and probably want to do something like call this edit book. Change the action to actually be the URL for the book, which is book.id, like that. If I close and execute that, then each one of those pages would contain an edit book field, and I can give it something like, let's say this was published in a reasonable year, like 2008. Not allowed. Method, not allowed. Oh yeah. I forgot to do the second part of method override, naturally, which is to actually, so you notice that this is actually a post to /books /book ID. And I don't have that defined anywhere in my routes. I have a post to to root. So let's actually go ahead and define a new one. Not that. To /book ID int. And we want to define this as edit book function, takes a book ID. Sorry. Actually, we don't need that. We already created this. An easier workaround is to just extend the function we already created to include post and put, like this. Basically, I'm replacing which is method equals put to be an array that contains both put and post. If we had an existing kind of post acceptor for that, we could modify it, but for now, this will be fairly sufficient. So let's try this again. I think I did things out of order. There we go. This exists, publication year 2008. There we go, it's changed. Author, this was written by Tomer, not Adam. Tomer, writing all the books in 2025. But yeah, so we've actually implemented most of it. All that's left is something you can delete an existing code book, which is actually very simple to implement since we have from our book model books app dot route. We give it some sort of book ID, and we want it to go ahead and delete it. Delete. Delete book, takes a book ID. And all it really needs to do is, if the book exists, I want to kind of import the object for it, the same thing I did earlier when I edited a book. And then I'm going to do book dot, did I call this method delete? That's a good question. Let's check our model over there. I don't have the model open? Oh, I have it over here. Yeah, I have a delete method in my model. So all I have to do is say mybook.delete, and it will go ahead and delete itself. And then we want to redirect to /books, because we don't have the current book to show anymore. If that doesn't work, let's go ahead and give you another 404. Couldn't delete something that doesn't exist. Book ID? What? This one?
First, no, second.
Okay.
Book ID.
Books. Oh, I see. This thing. Good call. PHP hammer. So that actually implements delete, but there's a missing step, which is basically we need to create the corresponding form for this, which is a very basic form actually. If we're over here, we just need to create a method equals get, and we use, sorry, the action is /books/book ID. You can copy paste it from the form right above this and just change the method to a get. And what we want to do with it is delete it. So we use method override the exact same way we did over here, adding a new input field and changing the method to be delete. Let's have a submit button. It's going to say value and be delete book. Like that. And now, so you notice that this form itself asks for get/books /book ID, which we actually defined, right? If I go into my controller at the very top over here, not at the very top, but close to the very top, I have this one, which is route book ID /book ID. So we want to actually do a little bit of checking over here and say if request.forms.get_method happens to be a delete, then what we do is we actually delete book ID. Basically, I'm calling the function, the underlying function for this route over here, right here in the case that the method that I'm provided is the method for deleting. And let's see. Sorry, there's a small change. Instead of form, it's query, because that a get would have a query string instead of an actual encoded form. Let's run this and test it out. Here are all my books. Here's a book I want to get rid of. Book ID is not defined. Okay, I must have copy pasted it correctly. What is saying? Sorry, over here. Book ID is not defined. Which line? 13. Oh, this is an error in my field over here. It's not just book ID, it's book dot ID. Seems to be a book over here. There you go. I can delete this book. Yeah, okay, deleted. Seems to take a second to update for some reason. Interesting. Must be because it's not asynchronous. Maybe not. Mass Effect, yeah. Mass Effect does this. Douglas Adams 2. And now we don't have any books.
Just like our apartment.
We have books. We have a book. Yeah, and that deletes a book. Another one for deleting all the books. It's actually fairly straightforward. Do I have a clear method over here? I just copy this, change it from being specific to one book to being just delete at slash or at root, and this will be clear books, clean. How did that happen? Doesn't take any parameters. All I need to do is just very blindly go to book.books and set it equal to nothing, and that will actually work. All we have to do afterwards is redirect. There you go. And so if we want to implement this as a form, because delete isn't implemented, we need to find the corresponding get, which is right here, the very first thing we defined, and do the exact same request, the exact same check as we did beforehand. If requested query get method is delete, then just call clear books and takes no parameters. Should probably go ahead and actually include this form somewhere. So this is the form for deleting a specific book. At the very end of our book list, let's have a corresponding thing that deletes all the books. Okay, I don't see any errors, so let's actually try it. If we start it again, we have all the books, and now all the books are gone. Title, a year, and an author. Bestseller? Nah, gone. This has to be a number.
Oh, I love that.
We have a lot of books in our library. Great variety. Not that one. Yeah, I think that this is all of the RESTful things. The second thing we wanted to do is we wanted to, as an exercise, include something, but I don't think we have time for that. No. So this is actually implemented in the sample code that I'm kind of attaching to this presentation. I added a thing that lets you basically check username, basically add user's name to a particular book, and then it just keeps a list of who checked it out. And just I guess for kicks and giggles, let's go back to my prepared thing and let's run that. And it actually looks very similar, except that something like the webdev has this checked out by, and Adam checked out his own book. And then he did it again and again. And then spam and spam and cheese and spam. And then the book was deleted. What's my IP? Oh God. Fine, fine. This is bad. No, Google knows. Does it not know?
I think you have to type in the IP. If you type in, yeah, if you just type in what you want to use, it will figure it out. No, but he probably, like, if he's on Wi-Fi, then you can't just access servers on his laptop.
Oh, I need to have ISS enabled.
Disabled, you mean?
Disabled. I call it enabled because I always take an action to disable it. So to me, it's feel like I'm enabling everyone else to access. See if you can make it work. I think you can make it work from if you initiate a local connection on the same router. Maybe not on GT Wi-Fi. Well, let's just see if people are doing anything. Too bad, Tomer. Too bad. Tomer is Tomer 2087 by Tomer. And this one actually supports description.
Couldn't have guessed it. This book is about web. It's not nowhere at all. Oh, the president checked out Tomer's book. Congratulations, Tomer.
This is how you spell Trebek? I never know if this is actually how you spell it.
Spell with a K. Yeah.
Okay, then why did I think that? Isn't this cooler though? Should he not change his name to that? Trebek? With a Q? There's a go back button over here. And the source code to this is actually provided to you guys. I don't know if Adam actually posted it to our event page. I think it did. Good. But all you have to do is go to our GT webdev page. Ideally. And this is lesson 05. And all of the code is available over there, and the screencast will be uploaded eventually. Oh God, where did I keep it? 9 and stop. How do I stop? God. Who?
Yeah, let's make awesome notes.
Awesome notes. They just save